as well. But again, this is just a list of features that you get from a proper relational database. But perhaps the most intellectually interesting one and the most powerful one is what's called here a primary key and a foreign key. And let me go back now to this output. If we look at shows, you'll see that a show, again, has an ID, a title, a year, and a number of episodes. And now the data types might make sense. The ID, it turns out, just like a Harvard ID, a Yale ID, is going to be an integer, so a simple number. The title, of course, is going to be text, but not null. Like, it would be weird if a TV show had no name. Like, that can't be. Like, the whole world would break, or your TV guide and whatnot. So that makes sense there to say not null. Year is numeric, so it's a standardized form. Episodes is an integer, like how many episodes have been produced. And then lastly, notice this. The primary key of the shows table is apparently the column called ID, mentioned a few lines earlier. This just means that the database will use the ID column as the unique identifier. So it's similar to the unique keyword, but primary key just means the database is going to treat it as special too and make sure that it is uniquely identifying your data. But what's interesting is this. Notice if I scroll back up to people, people were sort of similarly structured, but with different attributes. Like up here, we had a person has an ID, a name, a birth year, and a primary key of ID. So ID is, again, integer. Name is text, but not null, because it'd be weird to have a human with absolutely no name textually. Birth is going to be numeric, but the primary key of people is ID as well. So those are the unique columns that the database will just treat special. Why? Well, we just looked at shows. We just looked at people. Let's focus now on this one down here, stars. How do you determine who stars in a TV show? Well, we had two columns, the show ID and the person ID. This is the incarnation of a many-to-many relationship. One person could be in many shows. One show could certainly have many people in it or writing for it. But notice this. Within this table of two columns, show ID and person ID, there's what's going to be called a foreign key called show ID that references the shows table's ID column. And then another foreign key called person ID, though I could call these things in parentheses anything I want, that references the people table's ID column. Now, you're not going to often have to type commands like this. Again, you set the database up once in the beginning, typically, maybe with some help from a TF, maybe with help of Google or the like. But once your database is designed, it's back to the CRUD, like create, read, update, delete, the selects, the inserts, the deletions, and the like. But what's this implying? These keywords like primary key and foreign key are what are doing in code what this picture was painting a moment ago. These lines here are drawn literally to line up with the corresponding things. People's ID lines up with person ID. Show's ID lines up with show ID. And so you're just seeing graphical version, graphical code that creates these relationships. Now, given that, let's actually see what these things look like. So let me go back to VS Code here. Let me clear my screen. I'm still within SQLite with shows.db. Let me go ahead and do what I do with like any new database. If I ever download something or I'm trying to wrap my mind around a problem, usually it doesn't come with a pretty picture or a 3-hour lecture to explain what the data set is. Rather, you just have the data set and your own knowledge of SQL. So let me play around. So .schema shows me all of the tables. That might be a starting point. OK, this is interesting. I know what people are. Let's go ahead and show me all the people. So select star from people. I'm just trying to wrap my mind around what this data set looks like in a more user-friendly way. OK, that's already a lot of people. As you see the years flying by, there's been a lot of people in the TV business. So this was maybe not the best query to run, but this is indicative of just how large this data set is from IMDb. OK, when in doubt, and whenever you lose control over your computer, Control-C is your friend to interrupt. What would have been better? Because I don't think I need to know all the million people in the world. I could do like, limit me to 10 people. All right, and that's enough now to get a sense of like Fred Astaire has an ID of 1, first person ever, birth year of 1899, Lauren Bacall, and all of these other people from yesteryear. You see that they are the first 10 people in the database. So there's an example of some of the data. Now, if I want to wrap my mind around what a show is, I know it technically, I know it from the picture, but let's just look at some raw data. So instead of saying select star from people, let me go ahead and select star from shows limit 10. And OK, I've only heard of or seen a couple of these, but these are older shows at that. But I see that every show has an ID, a title, a year in which it debuted, and a number of episodes. But perhaps most opaque is going to be this. Select star from stars, where this is the table that associates people with shows. Am I going to see any names or show titles here? Not according to the definition we saw earlier. Oh, I should have done my limit. Let me interrupt that. Let me do that again. Limit 10. No. And this is where now you're definitely in the programmer world, because like this would be the most annoying spreadsheet to use on your Mac or PC ever. If you just had like a sheet with all of these numbers that associates one thing with the other, like my God, how do you figure out who this is or what this is? You have to like manually Control F or Command F looking for the data. But a database doesn't care. Once you know SQL, you can sort of stitch these things back together. So what you're seeing here are foreign keys. Foreign keys. Why? Because show ID corresponds to the same numbers from that other table called shows that has a proper primary key called ID. Person ID is a foreign key in this context because it refers to numbers that belong to, really, the people table and its ID column. So this is just a way of somehow linking them. And so if you think of, I always like think of this in my mind's eye as this. If this is like the people table, this is the shows table, and there's this middle table in between, the stars table, there's some way of like stitching those two together by lining up the IDs of one with the other and getting back some more data. So let's actually play with some of this data. How about we start where we emphasized earlier, genres. So let me go ahead and take a quick look at all of the genres in this database. So select star from genres. Star is usually going to be a little overwhelming, but it just gives me a sense of what the data is. But let's actually look at, let's go look at all of them there. OK, that's a lot. These are all official genres from IMDb. Let me, oh, OK, it went OK. It wasn't terribly long. Let me filter that down. So from genres where genre equals comedy, capital C, just based on the data I'm seeing. OK, so what am I seeing now? And in fact, let me limit this arbitrarily to 10, though I could limit it to anything I want. Here are 10 comedies. What are they? Well, who the heck knows? Like, all I know are the 10 show IDs. Now, I could do something like this. As we've seen before with SQL, I could do, all right, well, let's figure out what this show ID is. Select star from shows where the ID of the show I'm looking for equals what? 62614 semicolon. So I could like manually look it up by cross-referencing the other table. OK, so that was the show in question there, the first comedy in the data set. Let me look up the second one. So instead of that, let's do 63881, enter. OK, so that's that show. And let's do one more. And suffice it to say, this is just getting tedious and vulnerable to mistakes quickly. This surely can't be the way to do this. And indeed, SQL is going to let us do this a little more powerfully instead. Let's do this. Instead of getting this table temporarily with all these show IDs and all these genres, let's refine the query. So let's just select the show ID from the genres table where the genre equals, quote unquote, comedy. Now I have a big list of show IDs, all of which are comedy. How many? Well, I can combine ideas from earlier. I can just count all of those show IDs, or star if I want to just do that too. But I can count all those show IDs, 48,706 comedies in IMDb's database for TV shows. So it feels like a lot. But how can I now use that information and get back the titles of comedies in the database without doing it manually? Well, let's do this. I have a moment ago this query. Select the show ID from genres where the current genre is, quote unquote, comedy. What if I kind of nest these queries, kind of like grade school math in parentheses? What if I combine this whole thing in parentheses? And now let me select what I really want. Let me go ahead and select, how about the title of all shows where the ID of the show is in this list of show IDs. So if you agree that the shows table has an ID column, which is its otherwise known as its primary key, the unique ID that identifies it, just like our Harvard IDs, our Yale IDs, and you agree that per a moment ago, this shorter query will give me back just the show IDs of all of the comedies in the database, you can actually combine or nest these queries together. It's going to respect SQLite order of operations with parentheses, just like grade school math. So the thing in parentheses will be executed first. That gives it back a list of IDs, like what, 48,000 IDs. And then this query, the outer query, is going to get the title from all of the shows where the ID of the show is in that big list of 48,000. So if I now execute these together, I think the list is still going to be a little long, but let me execute it together. Now I see this long list of outputs, a little overwhelming. Let's go ahead and maybe limit it to just 10 as before for discussion's sake. And now I see 10 comedies ordered arbitrarily from however they're in the database that happen to indeed have comedy as their genre. If I want to do this a little more cleanly, I could do this. Let's see. Why don't I order by title, ascending order, which is alphabetically, or the default is also ascending, limit 10. Now I see the top 10, weirdly named things with hash symbols, presumably to get their titles up to the beginning, or maybe these are hashtags. Here now we have alphabetically the top first 10 shows that are comedies. Any questions on these kinds of queries? It's kind of a lot, but at the same time, it's just like composing the smaller ideas from before into slightly more useful queries. Yeah? Do foreign keys have to set the relationship? When you create the table, the programmer or the database administrator would create that relationship by using those keywords primary key and foreign key that teaches the database what is related to what per the picture. So you do that once. And now, I being the sort of programmer who's familiar with the database, I am just using these foreign keys in a manner consistent with their design. And this is where it's useful at some point, even if no one hands you a picture, to make sure you understand the database, because that's going to inform literally what you type in SQL to get the data you care about. Well, let's do something a little more precise. How about, very reasonable question, and honestly, this is exactly what imdb.com and the app are for. What if you want to find all of the shows that Steve Carell is in? Like kind of a reasonable query, like literally something someone might type into Google, or more specifically IMDb. It's not really obvious at first glance how to do that, though, because, right, like from my database, if these are my 6 tables, well, I can pretty easily get Steve Carell from here. But I can really only get his ID number, whatever that is, his name, which I know already, and his birth year. OK, interesting, but has nothing to do with the shows that he's in. I can look at shows over here. But there's no mention of Steve Carell, right? Because there's no person ID here. Where is that relationship implemented? Well, it's implemented down here. So how do we do this? Well, here's the perfect example of a lesson we've been trying to emphasize for weeks, of taking these baby steps, like break larger problems down into smaller ones. And let's do something like this. Let's just get everything I know about Steve Carell from the database. Let's select star from people, where the name of the person is, quote unquote, Steve Carell. I just want to see what data we've got. And here's what we have. OK, there's only one Steve Carell, born in 1962, and his unique ID is 136797, according to IMDb. This isn't some like global actor identifier per se. All right, well, how do I get now all of the shows that Steve Carell is in? Well, I could do this. Select star from stars, not to confuse the two. One's the symbol, one's the table name, where person ID equals 136797. So I think this will now give me everything from the stars table that relates to Steve Carell. OK, and you'll see person ID is the same, because I'm literally searching for just Steve Carell. But there are, what, like 20 or so shows that he's been in. All right, well, here's where things would get tedious. What are those shows? Well, I could do select title from shows where the ID of the show equals, and here's, whenever you copy paste, you're probably doing something wrong. OK, he was in the Dana Carvey show. Familiar with that? Well, let's do another one. We'll copy paste this, where ID equals this. Over the top, another. And if we keep digging, we'll probably find The Office. But my God, like that's going to take forever to do 20 queries manually. It's not very dynamic. But what if we just nest these queries a little more dynamically? So let me start from the beginning again. What if we go ahead and select everything we know about people whose name equals Steve Carell. That gave us earlier this data. I don't need all of that data. I know his name. I don't care about his birth year. So let's change this to just be, give me the ID of Steve Carell. And that gives me back now this smaller temporary data set. All right, can I now use this inside of another query? Well, let me wrap the whole thing with parentheses. And now let me say select star from the stars table where the person ID equals this. So I'm deliberately not using in because I'm assuming there's indeed only one Steve Carell in the world. So I'm not getting back a list of Steve Carells. I'm getting back the one and only in this case. So equal is fine. In is when you have multiple. Equal is when you have one. Let me go ahead and hit enter now. OK, that's more data than I need. I don't need like 20 copies of Steve Carell's person ID. So let me hit up. Let me go back and let me just get show ID from Steve Carell. And now I have a list of just the 20 or so show IDs that he has been in. All right, how can I now use this? Well, let me hit up. Let me put the whole thing in parentheses. And now let me select what I really want. Select title from shows where, and here's the final flourish, the shows table has an ID, has a title, has a year, and has an episode. And what I really want, though, is to check which shows have ID that is what? Anyone want to finish the thought? I just want to, yeah. Exactly, ID in this. And this is getting ugly. And when you actually write your queries in like a text file, you can format them nicely and indent them. My font is just getting, I don't want to make it too small to fit everything. But now we have 3 queries. One is in doubly nested parentheses. Then there's the middle one. Then there's the outer one. So this last query is going to get me the title from shows where the ID of the show is in this big list of 20 or so show IDs that Steve Carell is in. And I knew that because I looked up his name here. And notice what I did not do this time is I didn't manually hard code his ID number. There's no need. That would be kind of a bad way to implement a website if you're using a database underneath the hood. You want the IMDb for real to search for whatever the human typed in, and no one's going to know Steve Carell's person ID or anything else. So here, we've done this all dynamically. And now, if I hit enter, I think I get all of his shows. Let's go ahead and order this by title just to make it tidy. And you probably will see at least one or more shows that you know. And probably the most popular is ... The Office. So this is literally the kind of query that's being executed underneath the hood when you go to websites or apps like IMDb. Your textual query is probably being plugged into a longer SQL query like this, where some programmer at IMDb probably wrote this whole query in advance, weeks, months, years ago, and they're just somehow plugging in the value that you, the human, typed into the search box or the like. Questions now on finding this data or any other? No? OK, so where else could we go with this? Well, let's consider how else we might combine data. Suppose that the next question actually, perhaps appropriately, would be focusing in on not just like people and shows and these stars, but how do we kind of like gather more information about the shows themselves, like the genres, the ratings, or the like. So indeed, let's focus on just these 2 tables here. Recall that every show has an ID, a title, a year, and episodes. But it also might have one or more relationships with rows in this other table called genres. And this is so that a show can be a comedy, can be a drama, can be any number of other things, 1 row per. So you would see the same show ID again and again and again with a different genre written in English, like comedy, drama, or the like. Well, how do I kind of reconstitute that data? Well, turns out there's a few different ways to do this. And let me propose that we introduce this keyword here, join. And this is really the most powerful of the keywords in SQL itself. It doesn't have to be used. We've seen with nested queries that you can still select data across multiple tables. But here is another way. So let me do this. Let me go back to my SQLite database. And let me select sort of in one breath exactly the data I want. Select star from shows. And let's just limit this initially to 10 to see what it looks like. All right, that's again the shows data. Select star from genres. Let's limit that to 10 too, just to wrap our minds around it. And now this is not that useful. However, the data in the leftmost column here is the primary key in the shows table. These are just unique IDs. The data here in the genres table, recall, show ID is the foreign key. So it's the same numbers, but just copied into another table so that we can have this relationship across them. How do I kind of line up these numbers with these numbers to get back like a wider table that has title and year and episodes and genre and heck, ratings and all of that too if we want? Well, you can join these tables by just telling the database what to join on what. So let me do this. Select star from shows. Join that table, though, on the genres table. Well, how do you want to join those two tables? And again, the two tables from the picture look like this. How do you tell SQL programmatically to sort of, put one of them right next to the other, line up all of the IDs so that you just get one larger data set? Well, we can use indeed this syntax called join. So back to VS Code here, and let me join these two tables. Sorry, typo here. Join genres on the shows tables ID column, aka its primary key, equaling the genres tables show ID column, aka the foreign key. So in other words, it looks a little cryptic, but I'm just telling SQL how to line up these two tables and what column to match with the other so that the numbers line up and I get essentially a wider table. Let me go ahead and hit semicolon and enter. And this is now going to give me a lot of data. We might have to interrupt it. But notice, even at a glance, we're getting the ID, the title, the year, the number of episodes, the ID again, redundantly. But that's to be expected if I'm joining them, and the genre all the way on the right. Let me hit Control-C to interrupt. Let me just limit this to The Office. So where title equals, quote unquote, The Office. So we can focus on just one sample datum. And here, fun fact, there's been more than one Office. The one that you all probably like is this one that started in 2005 with 188 episodes. Its ID in the shows table is 386676. That's confirmed over here too. So again, we've just joined the two tables. How? By lining up those fields. But now that we can see that almost all of the Offices produced over the decades are comedies, except for this one. There was a version of The Office produced in 2001 that was considered more of a drama. No, unsure if it's related to the other. How can we link in other data? Well, let's go ahead and link in ratings too, or instead. So instead of joining this with genres, let me go ahead and rewind here and join shows on ratings on shows.id equals ratings.showid. And let's limit it to The Office too for discussion's sake, where title equals, quote unquote, The Office, semicolon. And now you can see that among the various Offices, it looks like the one that most of us probably know and love is the highest rated also, with a 9.0, with like 585,000 people having cast votes for it, whereas these other shows seem to have been less popular, and perhaps that's why, indeed, you see fewer episodes for them as well. So even though we've put the data in multiple places, you can still kind of reconstitute it by lining things up in this way and rejoining the tables. Questions now on this? Like, this is the heart of what SQL does and what relational databases do for you. Questions? All right, a few final features. Like, there's not all that much that, SQL takes practice like anything else. But in terms of syntax and capabilities, let's just introduce you to a couple of final features here and problems that arise and how we might solve them. Let's go ahead and how about we find something like, let's do this as well. So let me go back into VS Code here, and let's just find out Steve Carell's information again. Last time we did it with this nested query by getting his ID and then the show IDs and then the titles for those show IDs. With join, you can do it a little differently. And any of these ways are fine. One might become easier to you mentally than another. Let's go ahead and select the titles from what? Let's select the title from the people table. And I'm going to hit enter. And when you're using SQLite 3 interactively, if you ever find yourself with a prompt that says ... angle bracket, it means you're continuing your thought onto the next line. If you didn't intend that, you can sometimes hit semicolon to just end the thought and hit enter, and just even if it triggers an error. But this is one way of formatting my queries now a little more nicely. I'm just going to add some white space so that it's a little easier to read. What do I want to select? Well, I want to select the title of shows from the people table joined with the stars table on the people table's ID column equaling the stars table's person ID column. So in other words, if you think back to what people are and what stars are, one has an ID, one has a person ID. I'm just now connecting those two tables. I'm joining those two. But I want to do this as well with another table. Let me additionally join in. So now I only have two hands, but now I'm putting a third table joined in together here. Join shows on stars.showID equals shows.id. So this is now linking three tables together. But I only care about this for one person. So where the name of the person equals, quote unquote, Steve Carell. So more cryptic to be sure. But what we're doing with this query is just taking all three tables that we care about, and we're joining them all together at once using this new join syntax, literally telling the database what columns to line up with what. And then we filter at the very end, just like before, to get back. If I hit enter, the answer we want, which in this case is a little slower at the moment, but that same list of 20 or so shows that he's been in. There's one other way to do this. And again, these are all in the slides online, so you can repeat them without having to jot down everything. And we'll put them in the notes too. But there's another way to do this. I could also use an implicit join. So that was an explicit join because I literally typed the word join multiple times at that. But let me go ahead and select the title from these three tables: people, stars, and shows. And this might just be nicer because if you know what tables you want to select data from, just enumerate them, separated by commas, which you might prefer in your mind, where the people ID equals the stars person ID, and the stars show ID equals the shows ID, and the name of the person equals Steve Carell. So this is an implicit join. And honestly, I constantly reference my notes for some of this stuff too. It's not the kind of thing that's going to come like this to you after just one day. But it's just a different way of expressing the same thing. I want to select data from three different tables. And hey, SQL, here is how I want you to line those tables up so that I can get like-related data for Steve Carell. And this now will achieve the same results ultimately. Let me hit enter. And there we go. So a little slower, and the performance might vary based on computer, based on implementation of SQL, but I think I still have the same answers. Now suppose, as I'm often do, and I had to look it up again last time, suppose you forget how to spell Steve Carell's name. Is it two R's, two L's, or the like? Well, I could also do something like this. Select, well, let's just keep this simple. Select star from people where name equals, I've been deliberately getting it right so as to not embarrass myself. That's the Steve Carell I keep querying. If you forget, well, you could try searching for just Steves. But interestingly, there's a bunch of Steves. We don't know when they were born. But that's probably not the Steve Carell we want if we don't have his last name. So I could alternatively do, well, it's Steve, and then it starts with a C, I think. Well, it turns out there's another wildcard you can use in SQL. We used the asterisk to select all of the columns. You can, in quotes, use a % sign to say C something. So there's 0 or more characters after the letter C. And now this doesn't work because now I would be literally looking for Steve space C something. But recall earlier I mentioned that one other keyword, which is for fuzzier matching, so to speak, where it's like not exactly what you're looking for, but it's like what you're looking for. If you instead say where his name is like Steve space C something, now we'll get back a whole bunch of Steves, but I think now I could probably find the one I'm actually looking for if I don't remember his name. You can use multiple % signs. If you forget what his first name is, you could reverse the order. But that, too, is a very powerful SQL feature at that. Questions on these queries here? Yeah? Sorry? What about it? Oh, yeah, sure. So the query I used here, there's a lot of Steves whose last name starts with C. Oops, too far. The last query I executed was this one here. So where the name is like, quote unquote, Steve C % sign. So that's just another tool for your toolkit here. But you'll perhaps have noticed that those two, prior to that query, the joins I did were sort of slow. And honestly, this database isn't even that big. Like, yes, it has tens of thousands of rows in it. But like in the real world, and most of the apps you and I use a lot every day, or websites, like there's millions, even billions of rows of data. And like if I had to wait on like my computer here or my code space like a second or two to get the data, like that's not going to work for millions of users or customers, certainly.